Hello, everyone. I am Heather Kirksey. I head up the OPNFV project, and this is Chris Price, our Technical Steering Committee Chair. Also serves on the TSC and board for Open Daylight as well. And so we're going to talk to you today a little bit about the OPNFV project and some of the intersections between OPNFV and Open Daylight. So I'm going to get started with a general overview of what the project is, and then Chris is going to go into a little bit more detail about some of the technical intersections between the project. So let me just see a show of hands. How many people in here are familiar with the OPNFV project? Okay, great, a lot of you. All right, how many of you are not? Okay, cool. So I will go. So I will do some of that. So I'll do the introductory material. So, what is OPNFV? Oops. There we go. So OPNFV, you may have heard actually a couple of the folks reference it this morning in some of the keynotes. But we are a carrier-grade, integrated, open-source platform to accelerate the introduction of new NFV products and services. So what that means is that unlike a lot of other open source projects that are really focused on writing their own code to fulfill a particular need in the market, we actually integrate lots of different pieces from a number of upstream projects together into a platform that addresses the NFV needs of end users and operators. So our focus really is on doing integration and testing work, as well as taking requirements back up to upstream projects. And one of the goals around this is to help us come together as a community, as an open source group, have lots more people focused on the project so that we are able to get to NFV deployments in real life faster. So here is our membership list. And one of the things that I'm most excited about from our membership list is the fact that we have a nice array of both end users and vendors, and sort of large traditional telecom vendors, as well as smaller startups, hardware vendors, silicon vendors. So we have a lot of different great perspectives coming in from the industry on what we want to do. So we get a lot of good different feedback, and we can take into account sort of the needs of different parts of the community. So as I said, we're an integrated platform, and that means that because we don't want to fork upstream code, we don't want to do things on our own, we're not trying to reinvent any wheels that already exist. What we do is we work a lot upstream with our communities, and this is our fish swimming upstream, our OPNFV jammin' salmon. And what we really do is focus on building relationships with the developers and our upstream groups. So for example, when the context of the OpenStack Liberty release, we actually had a number of requirements projects that looked at different needs that we had from a feature perspective in the platform that operators needed for network function virtualization. And we actually took blueprints up. Oh, okay. And we actually took blueprints up to OpenStack for things like fault management that are actually being incorporated into the Liberty release. So one of the things we really want to do is build really strong relationships with our upstream developers, and that includes our Open Daylight community as well, and work upstream first, not fork, and learn the norms and cultures so that we can participate productively when we go and collaborate with our upstream groups. So we have, as I mentioned, we do a lot of requirements work. For example, the fault management capabilities that we took into OpenStack Liberty. Also, because we do a lot of integration work, we are in a position to find issues that come from things like the integration of OpenStack and ODL. You know, what makes it difficult to run these two things together, and what might be sort of bug fixes or features that you find specifically when testing in an integrated environment. We also do a lot of testing. We do functional testing. We do use case-based testing for NFV type requirements. We also do a lot of performance testing that enables us to find issues in our upstream projects that we can then also take up there with sort of the results of actual tests. So we're not sort of just going up and saying, oh, so-and-so doesn't scale, or this doesn't work, you know, sort of noise you might hear sometimes coming from various constituents in the industry that might have, you know, religious beliefs about, you know, one piece of technology or another, we're actually doing testing. So if we find an issue, it's a legitimate issue, and we can also work with the upstream communities to figure out how best to address it. So it's kind of a little bit about who we are, and I've touched on a lot of this already in terms of what we do, but you can think of what we do as sort of being in a number of pillars. Build and integration work. So I've talked about how we integrate different components of upstream technology across compute, storage, and network. We also create automated install and build and deploy tools as well, so that people are able to take that integrated platform and be able to install it reliably and repeatably sort of across different environments. I mentioned a little bit before our deployment and testing, so that's another big focus of what we do. Testing is not something you necessarily associate with an open source project, perhaps, although I know ODL has been pretty good about testing, but that's actually one of our key focus areas, is actually coming together and test, and especially hearing from our end user customers. So one of the, I think, neat things about OPNFV is that we do have such a close working relationship with so many end users that when they bring us their use cases, things like virtual CPE or virtual evolved packet core, virtual IMS, different things that are using this integrated platform, we can actually bring those and use those to test the platform and actually sort of exercise the platform in all these different use cases that people hope to be using in the real world for our platform. And then new requirements and features. As I mentioned before, we have a lot of requirements projects that are doing gap analysis around various areas that the service providers believe they need in order to use the various components in their actual real-life deployments. Across that, we have continuous integration. We've done a lot of work on getting our continuous integration tool chain, and as I think it was it Dan mentioned in the developer panel, as they were talking about ODL, use the same CI tool chain as OpenStack. We also use the same CI tool chain. So we're sort of aligned with our upstream groups that way. And then here underneath all the sort of various types of the software pieces that we use, we actually have a hardware infrastructure that's part of the project. And to put a little bit more sort of detail on that, our first release, Arno, the components that we actually integrated together are these that you see here. So Open Daylight as our SDN controller, plugging into Neutron, Open vSwitch, Ceph Storage, KVM as our open source hypervisor. And then talking about sort of our infrastructure, we have a project called Pharos that is a community federated test lab capability, and we actually use this in our first release. We use labs from Intel and Ericsson to actually do a lot of our development work and testing work in our first release. So we actually can say not only do we talk about having a federated community test lab program, it in fact was one of the first things that we stood up, and we actually used it in our first release. We also have a bare metal lab that we host ourselves within the Linux Foundation that we use for deployment testing as well. And you can also feel free to jump in at any point
jump off
if you want to. And just from a project point of view, in our first release, our Bootstrap Get Started project was our initial project that kind of came up with sort of what components we were going to build in our first release, as well as sort of the two different deploy tools around that. So we actually, in our first release, have deploy tools from Foreman and from Fuel that are able to go and auto-deploy the entire integrated stack together. We did some functional testing. This is an area that we really want to blow out and improve in our future releases. And then Octopus is the name of our continuous integration project. And let's see. So just a little bit more about Arno. Other interesting things about Arno. Arno is our first release. It was a developer release. It's really aimed towards people that are wanting to get to know the platform, start getting their hands dirty with sort of this integrated capability, want to start seeing how to maybe deploy some VNFs on top of it, put their applications on there, see how they work. It's really a developer-oriented release. And if any of you are familiar with the ETSI concepts, the focus of Arno was at the infrastructure layer of the ETSI architecture, so what's called the NFV infrastructure and the virtual infrastructure manager. Let's see, and so here's our project pipeline. And actually we this morning added more things to it, and we added more things to this last week. I think we're gonna have to get a bigger slide because of our projects. But you can kind of see how some of these fall into some of those different categories. So going forward in our next release, we want to add various deploy tools from various companies to the two we had before. So you can see some of those on there. Joyd is Juju from Canonical, OpenStake, the project from Orange, Fuel Apex is kind of the evolution, I guess, a little bit of our foreman groups. We also have Genesis, which is going to sort of coordinate amongst all of our install tools. And then we've got, well, Oscar's actually migrating to something else, but we've got projects around OpenContrail and ONOS as well. And so, you know, we have other SDN controllers, but as well as Open Daylight going forward. And then we have a bunch of testing ones, FunkTest, QTIP. QTIP is doing performance testing. Yes?
Yeah, platform performance.
Yes, VSPerf is looking at performance of the vSwitch and really doing a lot of deep performance analysis on that. We have some great folks working on that. And then all of those projects over there are our requirements projects that are looking at various capabilities of the platform. And this is a great way for people to get involved if they have sort of, you know, especially end users, if they know what they want to do with the platform, because then they can do this analysis and help us take things upstream. Some of the interesting things on here, Copper is around policy, DPAC is around data plane acceleration, predictions around you know, determining when faults might be happening, Doctor is around fault management, you've got resource scheduling, high availability, IPv6. Service function chaining, which is a new one that we've added recently, and we've been working quite closely with the ODL, SFC group, and a GBP group on that. And then Moon is security auditing of the platform. So these are some of the things that we are looking at in our, you know, for future-looking time frame. Our next release is going to be called Brahmaputra. So if you're trying to connect Arno to Brahmaputra, the theme is rivers. So Arno is a river in Florence, Italy, and Brahmaputra is one that begins in Tibet, flows through part of India and into Bangladesh. So with that, I'm going to let Chris actually start talking a little bit now.
So I'm going to talk a little bit about the intersection between OPNFV and Open Daylight. I've been involved in Open Daylight for a while, way back when we were moving from ADCell to MDCell, and some weird guys came and says, why don't we model drive this? Work on the TSC for Open Daylight. So I have a good history in Open Daylight, and I kind of know what's going on, and recently moved to the OPNFV project, where I'm working with the TSC to set that one up and get it rolling. If you look at the visions that we have, and I've just stolen from various documents, but Open Daylight's a platform for SDN technologies. It provides a controller function when you load in your graph features. Depending on which function you want, the platform will support it. This is ideal for something like OPNFV, where we want to be able to load in an SDN controller. We want it to handle the neutron pieces, and then we want to do other interesting things with it. So Open Daylight provides us with the right vision and the right strategy moving forwards. And from an OPNFV perspective, as Heather said, we're building a platform. We're building a runtime environment, a data center on demand, if you like. And we don't pick winners. What we try and do is expose capabilities and functionality. So we have a number of install tool chains, deploy tools, which we're bringing in because deploy tools are inherently coupled to the technologies that they're supporting today. And this is something we're working with each of the deploy tool chains to try and resolve. But additionally, we have room for all the SDN controllers to come in so that we can start to say, okay, how do we do open flow networking if we're using Metanet, or if we're using Open Daylight, or if we're using ONOS? How do we do BGP-based VPN peering using these technologies, which support it, which don't? OpenContrail, of course, is a great option for that. And we try and work with all the upstream communities that we can so that we can best understand from an industry perspective, what are the use cases that make sense, or what are the use cases you can trust from any of these components. and we try and do so in a neutral fashion, so we're not necessarily affiliated with any one implementation. If we have a quick look at the overview, again, as Heather said, what we do is on the far side. That's how we do things, that's how we organize, and what we produce is over here. Heather talked about the Pharos activity. Pharos is a global consortium of data center equipment. We have labs hooked up to our continuous integration and deploy pipeline, so we can deploy an OPNFV platform to any compliant lab on the globe. So we can deploy to China Mobile's lab, to Huawei's lab, to Orange's lab, to AT&T's lab, to Ericsson's lab, or to the Linux Foundation lab with the push of a button. And that's really the vision that we have. We want to be able to allow people who have a few blades lying around to spin up an OPNFV instance, pick your SDN controller, pick your deploy toolchain, pick what you want, deploy it, and then start to play with it, start to put things on top of it, or start to adjust it and see if you can feed back and work with the project to improve it. Ease of use for data center technologies is really part of our mission. From an Open Daylight perspective, we're really focused on the Open Daylight OVS networking piece. And Open Daylight fortunately covers all of that. It's not an OVS only, it's not a network only, it really has the scope to deal with everything that you might want to address. And how we work with that is on our deployment and testing and our new requirements and features side. So we have now deployed Open Daylight, Helium, we're moving to Lithium, we have it deployed already. And what we're starting to do is try it. We're starting to work with some of the applications that we want to deploy, complex applications like Evolved Packet Core with gateways and policy functions and things, and to try and tie these things together using Open Daylight as the networking component. And then we figure out what went wrong, or what didn't work, or if something could be improved. And we work then on the new requirements and features side. We work with the Open Daylight community, and we try and resolve those back into the platform. So we try and iterate as quickly as possible. We try and stay on trunk. We release twice a year, and we release stable. So we will release the Open Daylight stable release, the latest one. But when we work on a day-to-day basis, we try and work on trunk. There's no point us working on Helium for the next 6 months or Lithium for the next 6 months. We want to be on main when we're doing our development work. And when we release, we'll pick stable, just so that we have something consistent that we can stand by.
And I actually just realized this crowd might be slightly different. How many people do know what we're talking about when we say things like IMS or Evolved Packet Core or things of that nature? Because not, okay, all right, that's what I was afraid of. So,
I gave examples.
Telco people sometimes forget that telco people do not know all of our strange things.
Wonderful things.
Yeah.
Okay, yeah.
That high level is these are parts of mobile networks and fixed mobile convergent networks that do a lot of things around packet admission and traffic shaping and charging and things like that.
Could just as easily be a VCP backend. I mean, who knows?
Yeah.
Anything that you want to run.
I just realized we were using examples that might not be widely known in a non-telco audience.
All good. So we focus on NFV. So we're not just trying to build a data center. We're trying to build data centers that support NFV use cases, and we can build out into NFV environments. NFV is not just about virtual networks. You don't just spin up a virtual network. Full mesh Ethernet is great in my private data center. It doesn't really cut it in the NFV network. But on the other hand, it is about virtual networks when you consider that the network is an end-to-end construct that supports a use case that you need. So a virtual network in the context of NFV is an end-to-end construct. It has intelligence in the cloud, it has inbuilt security and isolation, but then it also exposes those capabilities through to the endpoints that you might have. And Open Daylight is great for us because Open Daylight provides us with features like SFC for mobility, security, and policy. You can do amazing things with SFC. L3 VPN and BGP peering capabilities that are coming out in Open Daylight now. This is what you need to talk to endpoints. This is how you peer things together. IoTDM for machine-to-machine is a capability in the platform now of Open Daylight. And of course, you have the packet cable, PCMM, and DOCSIS projects if you want to do residential use cases. And this is all available to us if we use Open Daylight. We can just run a caraf command, and all of a sudden we have an SDN controller which is going to support packet cable. And it's just great. Open Daylight, because of the Open Daylight community and because of the breadth of people that are coming, for a project like OPNFV, it's an ideal breeding ground for us to be able to pick up the capabilities we need to be able to do actual NFV end-to-end networking. If I have a look at the Lithium diagram, what are we doing today? Well, we got Helium integrated into Arno. It does ML2 networking, sort of. We got it to run. It's not ideal. We've moved up to Lithium. We're still doing ML2 networking, but what we've found with Lithium is we have cool things like GBP and SFC to play with as well. But from an OPNFV perspective, the starting point for us really is the OpenStack neutron piece. Then we talk about the neutron northbound capabilities we're going to be extracting, and then we can go through the OVSDB neutron, run down to the OVSDB and OpenFlow plugins, and all of a sudden we can spin up a data center network. So a couple of Karaf commands and we're good to go. If we want to do something a little more interesting, we want to bring in service chaining or different things like that, then what we might do is choose to go from OpenStack neutron to group-based policy. Group-based policy can implement service function chaining, and then we go back down to OVSDB and OpenFlow, and we can all of a sudden chain through the data center network. And so without changing the Open Daylight controller, we've actually changed how we're constructing the underlying data center network. Additional things of interest for us in OPNFV is the Open Daylight APIs. I might choose to try and deploy a data center network using Neutron, but Neutron gives me just enough to get what I need done. If I want to do advanced things, if I want to be able to play with the network, then I have another set of APIs that I can go straight to Open Daylight, and I can start to do things, and I can start to change the way the network's behaving dynamically by addressing Open Daylight directly. And this is extremely important when it comes to experimentation, when it comes to how we're going to build out advanced functions. In addition, things like virtual private networks, we need layer 2, we need layer 3 VPNs. These are really important. We need a BGP speaker. These things aren't all coupled together yet, but they're all kind of in place. And these are the sorts of things that we want to be able to do. We want to be able to deploy a network. We want to use the BGP VPN activity going on OpenStack to be able to peer that network using layer 3 VPN to some endpoint somewhere else, or to the edge router. In addition, we have PCP. PCP provides us the capability to talk to routing devices and do things like segment routing. So if we want to do service chaining in the data center and then segment routing across the WAN, these types of capabilities are available to us. It's just a breadth of capabilities. And of course, the DOCSIS and PCM PPCops allow us to do those packet cable types of technologies. So just if I look at the diagram that we have today, and I'm just thinking, okay, some simple use cases I want in my NFV platform, all I have to do is pick the ones I need, and I'm good to go. NFV networking is more than just data center networking. It's also complicated. But fundamentally, it's coupled to service enablement. If I'm running an NFV data center, I want to be able to do things with it that provide different services. I want to be able to isolate and have tenants that are providing different services. So the coupling to service enablement is really important to us when it comes to doing networking. Open Daylight provides us with a platform that provides these functionalities. And the one thing I would say about Open Daylight right now is that coexistence is critical for us. If I install an Open Daylight system, I need to be able to use that for multiple purposes. So coexistence of these functions is really important. A good example in Lithium was the coexistence capabilities that GBP and SFC team put together so that they're actually able to work together to solve the problems. A lot of other use cases that you can provide in Open Daylight don't play well with others yet. And coexistence is really important. From OPNFV, we see ourselves as a great avenue for Open Daylight communities to come out and validate that their functions work, validate that coexistence works, and validate the end-to-end use cases that we all really want to see come out in this domain. And coexistence is critical for NFV use cases. We cannot stress it enough. We have to be able to have multiple services over multiple tenants. And I'm just going to keep spinning that around for about 5 minutes until everyone sort of gets the message. But what's going on? Beryllium and Brahmaputra. These are the next Open Daylight and OPNFV releases. Hopefully they will live together for months to come. But some of the hot topics. From an OPNFV perspective, we want to be able to provide to the Open Daylight community automated, repeatable ODL bare metal deployment. We have bare metal labs across the globe, which is something which is rare for an open source community. What we're talking with the Open Daylight community is setting up a third-party CI system so that they can use OPNFV facilities to actually do bare metal testing of the Open Daylight controller on different types of hardware. We have a heterogeneous environment for hardware. So these are some of the capabilities that will improve the Open Daylight platform itself as we start to see where are these hotspots to pop up on different types of bare metal. Improved clustering and high availability of neutron networking is really important to us. It's there in Open Daylight, but it's not really fully there yet. You can't stand behind it and say it's always going to work and it's going to be great. There's some work to be done. But this is something that we want to work with the Open Daylight community. Policy-driven service function chaining. This is something we're toying with now, and it just seems to be so valuable. It's just one of those things that allows us to, without expending much effort or spinning up too many VMs at all, construct network paths enable security, enable isolation of tenants. It's just a great technology for NFV data centers. Of course, layer 2 and layer 3 VPN networking. Working a lot with the OpenStack community there at the moment and looking to work with the Open Daylight community to make sure that we have a peering capability there. Network SLAs, of course, from an end-to-end perspective, we need to see these sorts of things. There is an EPL service, which I think is being spun up in Open Daylight. It's not yet a project, but I think it's a proposal. But these are some of the things that we're looking at, working with the Open Daylight community, bringing into OPNFV, working together and exposing, and really driving forwards. And I think that's all I have, and I think we're way ahead of a schedule.
Yeah, so just, if you're interested in getting involved in what we're doing with OPNFV, if you're interested in sort of participating in some of our testing projects, kind of see how, Open Daylight's working, when deployed to bare metal, integrated with OpenStack in our environments. One of the nice things about our Pharos test lab project is that we actually have so many different types of environments that people are doing across different hardware vendors and even different hardware architectures. So it's a great way to test sort of portability of the platform. And then also our end users are connecting to Jenkins and deploying into their own environments, right? So someone like Cable Labs or someone like AT&T wants to see how something works in their own service provider environment. We provide a great way to make that happen. So it's a really great project to get involved in terms of taking sort of what you're doing and creating an Open Daylight and helping it get deployed in the real world in the service provider telco networking use cases. So it's kind of taking things kind of to the next real world deployment level. But so here are different ways to get involved, and we would love to see people. We always need more resources and more expertise. And as a community that collaborates with other communities, we are always as good as sort of the interfaces that we have and the interest and enthusiasm that we have from the folks that are working with us, and also helping us bridge into other upstream groups. So with that, we can just open it up for questions. Do we have any audience mics or?
Yep. Thank you. So you mentioned the carrier grade. So first question is, what's the definition of carrier grade? So second question is, do you ask all the upstream has a carrier grade? And more specifically, ODL is carrier grade or not? Thank you.
I think carrier grade is honestly in some ways one of those terms like obscenity. It's hard to define, but you know it when you see it. That being said, some of the things that are important to our users, and you can also jump in here, are things like high availability, and we do have a project around that. A lot of the things around FCAPS type functionality. So as I said, that's one of the features that we were interested in taking back into OpenStack, which was ensuring the ability to get fault management type information. So all of that type of fault configuration, all the FCAP, the traditional telecom FCAP stuff to make sure that that's still possible with these virtualized networking capabilities. And then I think also around throughput. That's definitely, when you're talking about sort of the packet throughput that you need for large-scale telecom applications, those are three of, I think, the big things that come to me when people mean, carrier grade, and things that we certainly have requirements projects focused on.
So carrier grade, if I was to define carrier grade, it would be to define that it's good enough for a carrier to use it. They're happy to use it means it's carrier grade generally, because as you say, it's very hard to define. And to that point, we don't expect that of our upstream communities. Well, we expect that. We go in and we say, okay, we just assume that this component is good enough for a carrier to want to use. And then we start to test it, and then we deploy it, and we work with the carriers. I mean, if you saw the start slide, we have AT&T, China Mobile, DOCOMO, Orange Telecom. We have a number of operators participating, working on requirements projects, and helping us to identify gaps and test the platform. So our approach is very much to try and then identify where are the gaps, and then go upstream and say, hey guys, we want to use this, but we see that there's a gap here that we need to resolve, and then try and bring that gap down and close the gap and bring it back out into the next release of the platform. So, I mean, as far as defining carrier grade, I won't try. As far as is everything carrier grade now, no, Amo is not. Amo is not carrier grade. No one would want to deploy this. We really span it up as a development release. Our next release is going to be starting to approach carrier grade, and we will know when we've done whether or not anyone's actually going to deploy it. My expectation is that we're not going to have closed enough gaps by then, and that's, I think, a realistic expectation. I think what we expect from the next release is that it's usable, it's easy to deploy applications on, it's easy to start to evaluate applications and compare them to each other. So it's maybe something which a carrier would put in their lab and really start to understand the platform, understand the constraints, and then we go through another iteration, and then maybe we arrive there. But to say it's carrier grade is not the case today. If you look at the components, again, ODL has HA, OpenStack has HA. You know, each of the components has aspects of what we want, but when you plug it all together, so the ODL HA and the OpenStack HA, well, they're not really playing that well together yet. So we're starting to work with the communities on those types of aspects as well. So it's not yet, but our vision is to have something which is to the point of everything functions well together and people are very happy with how it works. And that to me, as long as carriers are happy, we can call it carrier grade. I don't know.
In the slide you have there with the architecture overview, there was a couple of dotted boxes about the orchestration stuff, and that's it. So that kind of stuff is right there, or why is it dotted?
So the reason we have the dotted is for the Amo release, or for our current release and our current focus, it's to get these things running really well. We already are deploying VNFs, but not as an automated thing, not as something which we have spent enough time on to say, okay, now we have VNF support, virtual network function support. And the orchestration and management is also something that we know we're going to be there, but the definition of how orchestration and management should work and what we can expect and expose from the platform isn't yet clear enough for us to want to sort of jump there. So we leave them as dotted boxes in that these are sort of in our mind, but not currently where we're focusing and spending a lot of effort. So yeah.
But it's gonna be there.
Yeah. Eventually, yes.
Yeah,
Yeah.
well,
Well, not eventually, rather soon, I would say.
Yeah.
But yeah.
Yeah, and also just in terms of, you know, focus, getting sort of the platform more solid before sort of moving up the stack to other things. You know, if you start building stuff on a shaky foundation, you're going to have a shaky thing.
I can orchestrate and spin up a whole enterprise carrier grade network, or enterprise carrier network, but the platform I'm running it on sucks. So that's not really where we want to end up. Was there a question at the back?
Actually, my question relates to one asked. But for example, if you're talking about, thank you. If you're talking about management aspects of VNF and looking at Taka project appeared in OpenStack, does it, okay, OPNFV plans to collaborate with OpenStack community, let's say, inside of the Taka project, which is focused on the VNFM layer?
There are OPNFV members involved in the Taka project. At the moment, it's still in that dotted box, so we're not focused on trying to bring it in right now. We still have to get our heterogeneous platform up and running. So I would suggest in the Brahmaputra release that we're really going to be focused on getting that platform in place. But we are talking with projects like Taka, and we're discussing with them what's going on, what we're focusing on, and they're discussing with us what they're focusing on. And I think once we get to the point where we start to address the Mano stack, we're probably going to be finding ourselves just working naturally with these guys, because we've been talking about the interfaces and the use cases, we've been talking about the exposures that we can make, and they'll be starting to adjust to what they think will be available there. I think the industry in general is all heading in generally the same direction. There are a number of initiatives in the Mano space that aren't the same, but are in the same domain, so it's not equal across the domain. But at the end of the day, I think when we start to work closely with those projects, they will know what to expect from us, and we're going to know what to expect from them. So when they come in, I think it will be a natural fit.
Another related question. If someone will come to you and suggest some orchestration project inside of OPNFV, you will reject it immediately, or you will always discuss, consider that you can do it?
So to say, in the timing of the Amo release, we didn't really want to discuss Mano. So we asked people not to propose Mano-related activities. And at this point in time, I think we still don't want to spend a lot of time on Mano-related activities, but I'm not sure we would be so strict anymore as to say we don't want to talk to you. I mean, we're already talking to these communities. And the question of a Mano project, so TAC is a really good example of a project which is doing Mano, who we're talking with, but they're not part of OPNFV yet. And I think when we're ready to address that, then we can create our own working group towards that and start to integrate that. It's just a matter of timing. I think we need to get comfortable with what we have before we start to bring them in. But if someone was to start up a project in the Mano space, they can come and talk to us, but I'm not sure that we'd be ready to spin up a project that relates to it yet, if that makes sense.
Addressing issues with Neutron might be higher priority, perhaps,
Ah,
at
well,
the moment, or I don't know.
It's a good place to spend time. Yeah. Goodness, yeah.
When I download Arno, do I get an installer that installs OpenStack Juno, ODL, Ceph, and all these components that work together? Or is it more of a recipe for me to go download the right components from Upstream?
Yeah, good question, actually. So for Arno, we took a decision that we wanted to provide a consistent and stable image. So we actually create an image of the stack for Arno. So when you download Arno, you actually download something which you would put onto your jump server, and then it would go off and it would pixie boot to all your other servers, bring up all the operating systems, deploy the networking, and bring up the whole open stack. So it's not a scripted solution in Arno. We chose to go with a complete ISO solution. Moving forwards, we may have both. We may have one or the other. That I think is open for discussion. A lot of people prefer the scripted solution that will essentially run a recipe for you. Others like to have the ISO in their hands and just be able to go into a lab with a closed door and bring everything up. So we haven't yet made a decision on Brahmaputra as to whether we'll support one or the other or both. But for Arno, it's an image. It's a bootable image. We have two deploy tools, so we have the fuel-based one and there is a Foreman one. In the Brahmaputra time plan, the Foreman project is now called Apex, and it's going to migrate to the audio manager solution rather than the Foreman-based solution. Cool. Any more questions?
Any more questions?
Yeah.
I was curious to know how does your network relate to things that are done by some of the standards that are being set by ONUG, some of the work groups that are there under ONUG, and let's say when ONF. I'm just curious to know what's the interrelation. You talked about the effort that you're doing with Open Daylight, but the other user groups that are there under ONUG and ONF. Well, what kind of relationship do you have with them?
Different for different groups, I would say. We have a very strong bonding. We have a good relationship with the NFV ISG. That's really what spawned the whole activity. So we have a good dialogue with them. We have a very good relationship with the ITF teams who are starting to look at things like service chaining and the various standards we need there. We have good relationship with the ONF. We have a couple of VNF forwarding graph activity. We have OpenFlow, of course. We do a number of things the ONF is producing. For ONUG, we have established relationships with them. A few of us are invited to the ONUG NSF working group now. And what we're planning to do there is to help support them. So we want to run the test cases that the NSF team are coming up with to make sure that our platform supports NSF-like workloads. So we are proactively approaching all SDOs, and we really want to make sure that we're not saying, okay, we're this house or that house. We're wanting to produce something that's useful to as many people as possible. Cool.
Could you pass the microphone back over that way? I couldn't hear you.
We're using. Well, under the storage virtualization, we're using Ceph object. What was the database? Yeah. So the question was which database are we using, and we're using Ceph. We have projects under discussion, not yet under review, which would introduce additional database components so that you'd be able to choose which type of database you would want to deploy. But the database itself wasn't something we thought we wanted to spend a lot of time on in Arno. We had a lot of work to get done in 8 months, so we just picked Ceph. It just plugs in and goes. So.
I don't get Ceph as database is in a storage?
Storage, yeah. Sorry. Oh, okay. We don't have a database as a service solution. We don't have a database. Yeah.
And we just have the databases that are whatever's sort of default with.
Well, for OpenStack, yeah.
Yeah,
I mean,
for OpenStack and
we
ODL.
don't provide databases as a service to applications at this point. In the control blades, you mean, or on the compute blades? I mean, so the control blades. So in the control, we use OpenStack, and we use the default that comes with OpenStack. Yeah, and the same for Open Daylight. We use the default that Open Daylight provides. We haven't done any optimization on the control side yet. Yeah. Yeah. Yeah.
I talk loud because I'm obnoxious, so I might not need the microphone. I'll talk really loud. So I'm involved in a new project that's just starting with OPNFV, and one thing that occurs to me is I played around with building it a little bit in anticipation. When you have a project that has like downstream dependencies with other OPNFV projects, do they all, when we build it, do they all get built, or is there a way to sub-select projects, and how exactly does that work, or am I asking a very, very stupid question?
For the packaging of components, you mean?
Yeah, in terms of packaging the components of one project
Yep.
and its dependencies on a second project within OPNFV, like for, you know.
You're asking a very good question. So in the first release, we cheated a little bit. Well, we didn't cheat a little bit. We didn't address the problem, I guess, intentionally, because we wanted to focus on our infrastructure side. But in the second release, we're going to have a heterogeneous platform, which means we're going to have to be able to hot swap or just select packages dynamically. In some cases, packages are available for us. If we're running on CentOS, then we can take the RDO packages, for instance. If we're running on Ubuntu, we can take the Canonical or MOS packages for the components that make sense. For things like running trunk Open Daylight, then we need to download that and we need to package that ourselves, and we need to then inject that into the platform as we build it out, as we deploy it. So there's no simple answer. In some cases, we take prepackaged components where it makes sense, and in other cases, we have to build our own because we're doing real-time trunk development or something.
Well, thanks. Is it the responsibility for, like, for example, just let me pick on it, like for the Open Daylight package? Is it is it the responsibility of the Open Daylight project in OPNFV to suck in the Open Daylight package, or is that?
Okay, so it depends, and it depends on our relationship with our upstream community. So Open Daylight does a nightly build, and they provide a nightly package, a nightly build. So we actually have access to whatever happened the day before. But if I'm doing some dev work in OPNFV that I want to upstream to Open Daylight, and I'm building locally, and I want to be able to test in real time, then I'm going to have to be able to package that and put it in myself, and that's okay. We have all of our deployed toolchains are pluggable. So you can script that in yourself, and you can make adjustments. It's just part of how they need to be. And it's also part of how the industry is going. So they're pluggable in that you'll be able to hot swap in your own adjusted ODL controller if you want to in order to run some new tests and things like that. But it is a manual process for you. That's not really automated at this time.
So I'm sorry, I'm dominating question time here, but so it's a responsibility for each project to decide whether it wants to use a prepackaged component or whether it wants to suck in its daily build a component from the upstream project. Okay.
Yeah. Good. We have 2 minutes left. Yeah.
Yeah. Speaking of dominating, we'll take another question from the gentleman in the back. Do you mind using the
grab
microphone?
the mic, yeah.
Okay. So the question relates to VNF forwarding graph project, which was initiated for Arno release, but it looks like there are no artifacts which produced in Arno release. And does it mean that SFC project is going to replace something which was intended for VNF forwarding graph project?
So Not necessarily. I mean, it's like, is Open Contrail going to replace Open Daylight? No. You should be able to choose which you want to use. VNF forwarding graphs has a slightly different approach than the SFC activity. SFC is pulling in the Open Daylight. It has GBP inherently in it. The forwarding graphs activity is really, I mean, if you take the longer name, it's OpenStack-based VNF forwarding graphs. Their focus is on trying to take the SFC capabilities and the construction of forwarding graphs up into Neutron and have OpenStack supporting and constructing those forwarding graphs. They didn't get that into Arno. They're working with OpenStack now. It'd be great to see that coming through in Brahmaputra. Whereas the SFC project is really looking at leveraging what's available in the controller today from an Open Daylight perspective. So they have different targets. They can live happily together. Once we have that OpenStack capability, it'd be great to see that mapping to the work done in Open Daylight as well.
Isn't the VNF forwarding graph project a requirements project?
It's a requirements and some upstream development. Like they work with the OpenStack, so they're writing requirements towards the OpenStack project and implementation, yeah. So SFC is a little more, yeah, leveraging what's implemented. Yeah.
All right, one last question.
So how do commercial components fit in the platform? Do they need to get certified, or what is the process?
So there's no certification or anything like that. Basically, what we want to be is a pluggable, heterogeneous platform. So if you have a commercial component, for instance, let's say I'm deploying OPNFV and I'm using Open Daylight and I want to try Nuage, then I can download Nuage and I can write a script and swap that in for Open Daylight and run that on the platform. Now, that's exactly how we intend it to be. You need to be able to plug in commercial solutions. You need to be able to plug in commercial storage. You need to be able to do this sort of stuff in order to really vet the platform and understand how it's going to work when it comes to real commercial deployment. So that's part of our plan. What you won't see is we won't be creating a distribution that contains any commercial software. We only create a distribution of open source softwares. We don't create distributions of commercial softwares. But it's perfectly okay for someone to set up an OPNFV lab and then to have some, for instance, EMC storage solution sitting there, and they want to basically run the OPNFV platform against a commercial EMC storage solution and see how it works. That's perfectly okay.
All right, we are not early. We are exactly at time. So thank you, everybody, for coming to the presentation and asking lots of great questions. Particular need in the market. We actually integrate lots of different pieces from a number of upstream projects together into a platform that addresses the NFV needs of end users and operators. So our focus really is on doing integration and testing work, as well as taking requirements back up to upstream projects. And one of the goals around this is to help us come together as a community, as an open source group, have lots more people focused on the project so that we are able to get to NFV deployments in real life faster. So here is our membership list. And one of the things that I'm most excited about from our membership list is the fact that we have a nice array of both end users and vendors, and sort of large traditional telecom vendors, as well as smaller startups, hardware vendors, silicon vendors. So we have a lot of different great perspectives coming in from the industry on what we want to do. So we get a lot of good different feedback, and we can take into account sort of the needs of different parts of the community. So as I said, we're an integrated platform, and that means that because we don't want to fork upstream code, we don't want to do things on our own, we're not trying to reinvent any wheels that already exist. What we do is we work a lot upstream with our communities, and this is our fish swimming upstream, our OPNFV jam and salmon. And and so what we really do is focus on building relationships with the developers and our upstream groups. So for example, when the context of the OpenStack Leopardy release, we actually had a number of requirements projects that looked at different needs that we had from a feature perspective in the platform that operators needed for network function virtualization. And we actually took blueprints up. Oh, okay. And we actually took blueprints up to OpenStack for things like fault management that are actually being incorporated into the Liberty release. So one of the things we really want to do is build really strong relationships with our upstream developers, and that includes our Open Daylight community as well, and work upstream first, not fork, and learn the norms and culture so that we can participate productively when we go and collaborate with our upstream groups. So we have, as I mentioned, we do a lot of requirements work. For example, the fault management capabilities that we took into OpenStack Liberty. Also, because we do a lot of integration work, we are in a position to find issues that come from things like the integration of OpenStack. Hello, everyone. I am Heather Kirksey. I head up the OPNFV project, and this is Chris Price, our Technical Steering Committee Chair. Also serves on the TSC and board for Open Daylight as well. And so we're going to talk to you today a little bit about the OPNFV project and some of the intersections between OPNFV and Open Daylight. So I'm going to get started with a general overview of what the project is, and then Chris is going to go into a little bit more detail about some of the technical intersections between the project. So let me just see a show of hands. How many people in here are familiar with the OPNFV project? Okay, great, a lot of you. All right, how many of you are not? Okay, cool. So, I will do some of that. So I'll do the introductory material. So, what is OPNFV? Oops. There we go. So OPNFV, you may have heard actually a couple of the folks reference it this morning in some of the keynotes. But we are a carrier-grade, integrated, open-source platform to accelerate the introduction of new NFV products and services. So what that means is that unlike a lot of other open source projects that are really focused on writing their own code to fulfill across different environments. I mentioned a little bit before our deployment and testing, so that's another big focus of what we do. Testing is not something you necessarily associate with an open source project, perhaps, although I know ODL's been pretty good about testing, but that's actually one of our key focus areas, is actually coming together and test, and especially hearing from our end user customers. So one of the, I think, neat things about OPNFV is that we do have such a close working relationship with so many end users that when they bring us their use cases, things like virtual CPE or virtual evolved packet core, virtual IMS, different things that are using this integrated platform, we can actually bring those and use those to test the platform and actually sort of exercise the platform in all these different use cases that people hope to be using in the real world for our platform. And then new requirements and features. As I mentioned before, we have a lot of requirements projects that are doing gap analysis around various areas that the service providers believe they need in order to use the various components in their actual real-life deployments. Across that, we have continuous integration. We've done a lot of work on getting our continuous integration tool chain, and as I think was it Dan? Stack and ODL. What makes it difficult to run these two things together, and what might be sort of bug fixes or features that you find specifically when testing in an integrated environment. We also do a lot of testing. We do functional testing. We do use case-based testing for NFV type requirements. We also do a lot of performance testing that enables us to find issues in our upstream projects that we can then also take up there with sort of the results of actual tests. So we're not sort of just going up and saying, oh, so-and-so doesn't scale, or this doesn't work, sort of noise you might hear sometimes coming from various constituents in the industry that might have, religious beliefs about, one piece of technology or another. We're actually doing testing, so if we find an issue, it's a legitimate issue, and we can also work with the upstream communities to figure out how best to address it. So, it's kind of a little bit about who we are, and I've touched on a lot of this already in terms of what we do, but you can think of what we do as sort of being in a number of pillars. Build and integration work. So I've talked about how we integrate different components of upstream technology across compute, storage, and network. We also create automated install and build and deploy tools. as well, so that people are able to take that integrated platform and be able to install it reliably and repeatably. So